What's up guys, so right now we have the Arduino Duo right here and the sensor. This sensor is the time of flight sensor or LiDAR sensor. It is a light radar, so basically it measures the distance between a specific object and the sensor. The sensor is this small black sensor right there. So as you can see, it has a I2C interface, so you could connect this to multiple I2C interfaces and assign different IDs. It only measures about less than an inch or half an inch across, and the width would be 1.5 or almost 2 centimeters. So if not inches, it would be about 2.5 or 3 centimeters by 2 or 1.5. So this is a very small sensor. It can measure distances. Okay, I'm using the Arduino Plotter right now, and I could plot my distance. Oops, it's not, well, it's still scaled up. So let me normalize the graph. So this is the graph. I'm plotting the distance using a sine wave. You could use another waveform. You could use a triangle wave or a sawtooth wave right there. Oh, hey, you can make any kind of waveform, but a lot, aside from any other sensors that can measure distance, like the ultrasonic sensor, this time of flight sensor or the LiDAR is more accurate. It has a narrower minimum distance, and it can measure up to 2 meters, which is almost the same, like the almost the same as the ultrasonic sensors. Unfortunately, this one is a bit more expensive. Let's say 5 times the price or 6 times the original price of the ultrasonic sensor. It uses light, it doesn't use sound, so it's immune to it's immune to a lot of echoes, especially when there's in a closed area or chamber. It uses light to check the distance. It measures the time of flight of the photons going forth and back. I think it uses some kind of I call this Doppler effect kind of thing. So as you can see, this can measure up to 2 meters, but as you go farther, it will reduce its accuracy. So it's really accurate, less than half a meter. It's really accurate if you want leveling meter devices and fast response devices. This is almost instantaneous. I'm using the Arduino Duo just because I don't have any other Arduino Unos that are readily available right now. So you can see I'm plotting my distance from the hand to the sensor. This is very useful in a lot of instruments, maybe a keyboard, a tremolo, or a frequency changer, a shifter, pitch shifter, or some kind of control with your arm. Okay, it's a unique kind of sensor. It's fast. It's easy to work with since it's using I2C. It doesn't use any more timing. Oops, there's a stray. Yeah, it occasionally does that. There's a stray mark, especially if you don't put a lot of objects in it for a long time, especially when you just karate chop it or when you instantaneously place your hand there. It will sometimes inaccurately measure the distance. That's one issue right there. Unlike ultrasonic sensors, it's doesn't do like spikes. Okay. Also, when you use infrared sensors compared to this one, infrareds are very cheap, easy, but they're not accurate. You can only sense a very few amount of they can sense very close distances, but they cannot measure it accurately. This is for measurement devices accuracy. So you might want to limit this one, place a limiter in the program, but this was a raw example continuous measurement program. So that's it. Very easy, very simple, and that's the time of flight sensor. Hope you like this video. Please like, share, comment, subscribe. Okay.